Good morning, boys and girls.
Today we are going to do lesson 16-4, line symmetry. I can recognize and draw lines of symmetry and identify line symmetric figures.
So let's get started. What is line symmetry?
So a figure is line symmetric if it can be folded on a line to form two matching parts that fit exactly on top of each other. The fold, what?
Oh no, I was just saying, okay.
The fold line is called a line of symmetry. There is one line of symmetry drawn on the picture of the truck. How many lines of symmetry do the figures below have? So if you look at the truck and you fold it across that dotted line, the right side of the truck will match the left side of the truck and fit exactly on top because both sides are the same.
I'm kind of thinking like when we're folding something, it's like we have this Post-it here and we're just folding it to see if we could have the same shape.
Yep. If
we're going to fold it on that dotted line like this.
Yep, and the one side matches up with the other side.
Perfect.
And if it doesn't match, then it can't be symmetric. So let's take a look at these other figures.
So a figure can have more than one line of symmetry.
This figure is line symmetric. It has two lines of symmetry. It can be folded on each line of symmetry into matching parts. So you can fold it from the top down or from one side to the other.
Cool. A figure can also have many different lines of symmetry.
This figure is line symmetric. It has 6 lines of symmetry. It can be folded on each line of symmetry into matching parts.
So every time we folded on those 6 lines, we would have matching parts.
Yep.
Cool. There's another type of figure that could have no lines of symmetry.
This figure is not line symmetric. It has 0 lines of symmetry. It cannot be folded to have matching parts. And like one way we can tell that is because if you look at the sides of the shape, you can see that both sides are different. Like it goes in at different points and out at different points. So if you were to fold it, it's not going to fold perfectly.
There's nowhere that we could fold this that would be the same matching parts on either side. Cool. Let's take a look at an example. So this question is saying, find 2 capital letters that have exactly 1 line of symmetry. Find 2 capital letters that have exactly 2 lines of symmetry. So Ms. Schultz, what do we need to find here?
So I need to find 2 capital letters that have 1 line of symmetry and 2 capital letters that have 2 lines of symmetry.
So what do we know already?
So we know that a figure is line symmetric if it can be folded on a line to form 2 matching parts that fit exactly on top of each other. The fold line is called a line of symmetry.
So we could check each letter in the alphabet with like a dotted line to see if we would have matching parts on both sides.
Yeah, if we put a fold line on each letter going down horizontally, going down vertically and then across horizontally, we'll be able to tell if we fold it on that line, will it match up to its opposite side?
Cool.
So let's start with letter A. Let's start with finding 1 line of symmetry first.
Maybe we should try each letter vertically like this and then go back and try them horizontally.
Perfect.
So what do we think of the A?
So if I were to fold that A across over to the other side, I think it would match up because both sides of the A are the same shape. So that has at least 1 line of symmetry, the letter A.
Bring that for our answer. Cool, great. Let's look at the B. Does this work?
So if I were to fold it over, it's not going to match up because the right side is like rounded where the left side is straight. So I can tell right away both sides are not the same. So they will not match up.
Let's try C.
Same thing with letter C. The right side is like 2 little parts and the left side is like 1 long part. So they're not going to match up.
So maybe we should look through and see if we see any letters that look the same on both sides quickly. So before we bring the fold. So what do we think about the next couple of letters?
Not D, not E, not F, not G. H looks like it's the
Yeah.
same on both sides. So if we were to put, the line of symmetry down the middle and fold the right side on top of the left side, it would match up perfectly. So H is definitely has one line. But this has one line. We're only doing one line of symmetry.
So let's check I.
So I too would fold over and be identical as well.
Okay, so we'll keep that one in mind too. Any other letters that we can jump to that we think look the same on both sides?
How about letter M? That looks like it's the same on both sides.
Definitely.
Like if I were to fold the right side on top of the left, it would be the same. Not N. How about O?
Yeah, I think it would be.
Yeah. And I think it might have more than one line of symmetry, so let's keep that one in the back of our mind too.
Okay.
Not P.
What about T?
Oh yeah, T could definitely be.
Let's see. What do you think?
Yeah, both sides look exactly the same, so that works.
Cool.
How about U?
Yeah, I think that one could be too, because if we put the line of, sorry, it got stuck. If we put the line of symmetry in the middle, when we fold the U, both sides look the same. They're
Are the
matching.
same. Yep. So if that means U, then maybe V? I think V could work as well.
Definitely.
Yep.
And I'm thinking of W because I'm thinking kind of like it's an upside down M.
Yep. And if M has a line of symmetry going vertically, then so does W.
Any
And then
more?
X looks like it could have a line of symmetry going down the middle.
But I think that might have two. What do you think?
Yeah, because I think if we were to fold it going up, it will have a second line of symmetry. So we'll hold on to X.
What about Y?
And Y, yes, definitely Y. But it looks like it only has one, because if we were to fold it up, that long part of the Y would go in between the middle, and it's not the same. So that only is one line of symmetry.
What you're making me think now, when we check horizontally, we have to think, instead of if the left and right are the same, we have to think if the top and bottom of the shape are the same.
Yep. So like all the shapes on the bottom that we chose, I'm sorry, all the letters on the bottom that we chose, A, M, T, U, V, W, Y, have one line of symmetry going straight down through them, and both sides match up. Not the top and bottom, but both sides. Because if you were to take the top of the A and pull it down over the bottom, it's not going to match up the same way. The top of the A is very different than the bottom of the A.
Yeah,
so if we were to fold it over, it won't match.
What's on the top is not the same as what's on the bottom.
But let's look at B, because we knew that B did not have a line of symmetry going down. But if we go up, like matching the sides, if we match the left side to the right side, it's not symmetric. But let's see if we match the top side to the bottom side, if it's symmetric.
It actually looks like it would be, because we have this, it actually looks like two little D's, and they would just fold right on top of each other.
Yep, so that could have been one that is, we might have to create a post-it for that one. That could be one that has one line of symmetry, but going in the other direction, going from top to bottom instead of side to side.
Perfect. What do we think about C?
I'm thinking that if you put the top of C onto the bottom, it would match up. They're like the same from the top to the bottom.
I agree.
And I'm thinking the same thing about the letter D, because I'm just like noticing that if I were to just fold that letter from the top to the bottom, it would be the same.
I just noticed that I actually put the line on D and E, but what do you notice about E, Ms. Schultz?
I'm noticing that E can be folded from the top to bottom and match up as well. So E has one line of symmetry too. Yeah. So before, these didn't have lines of symmetry going from like side to side, but they have it going from top to bottom.
Down, yeah.
So it looks like if we were to fold F from the top to the bottom, it will not be the same. Now, like top of the F will be like hanging off on the bottom.
Yeah.
Same thing with the letter G. If we folded it on that line, it would not match up. Let's look at letter H.
Well, we already all knew that H worked the other way too. So I'm kind of thinking it works this way as well. So I think it has two lines. Is that
Yeah,
possible?
that has two lines because it doesn't matter which way you fold it. If you folded it left to right, it would be the same, or top to bottom, it's going to be the same. So that has two lines of symmetry, H.
Amazing.
I'm also thinking the same thing about the letter I, because we know it had the line of symmetry going down, like so you folded the sides, it was the same. So now when you put the line of symmetry going across, if we fold from top to bottom, it's going to be exactly the same too.
Cool. I don't think the same would be for J because it kind of has that little loop.
Yeah,
Bottom.
I don't think that's going to work for J. Let's take a look at K. So if we were to fold K, yeah, from the top to the top and bottom would match up. It's just not symmetrical on the sides.
Yeah.
How about L?
I don't think so.
No. How about M?
I don't think so. A lot of the next shapes kind of don't, the next letters don't look the same on the top and the bottom.
Yeah.
What about S? They both have loops. Would you think that would work?
Interesting. That's a good, I actually don't think so, because my only reasoning with that is the left side of the curve and the right side of the curve are not going to match and lay on top of each other. They're going to be like
opposite
they're
sides.
going to yeah, if they were on the same side, then they would match up, but they're not going to.
Like so, the B.
Yeah.
So they're on the same side.
S is not a symmetrical letter at all. It doesn't have any lines of symmetry.
No.
How about T is not going to work? What about U? No. If we went, no. V?
No.
No. W?
What about X?
No. Oh, yeah. Look, I think X will, because the top, it looks like it matches the bottom, and it would match up to each other if we folded it from the top to bottom.
And we already had it on our list from side to side, so that must have two lines of symmetry.
Yep. And then Y definitely does not have that second line of symmetry. We said that before. And same thing, like Z is like the letter S, like the sides and the tops and bottoms don't match up. They're kind of like opposites of each other.
So what I'm going to do is I'm going to put this here on top of the B, D, K, C, and E, and this kind of like in the middle here, so that we know that which way we found the symmetry.
Yep.
So why don't we take a look at the next question? This question is asking to tell if each line is a line of symmetry. So we're looking to see if when we fold it, they match. Is it going to match? So let's think of it. Do you want to use the pointer, and then we can kind of like fold it vertically? So if we went to that one right side and that one right corner, will that right corner match up, or the right corner? I'm sorry.
The bottom right corner? Yeah, if we folded it across over, is that line going to match up to the other corner? I think so. It looks like both of the sides are the same.
Like I'm thinking it would be a straight line, then a little diagonal line, and then another diagonal line.
Yeah, and then the other side is a straight line, a little diagonal line, and a little diagonal. So I would say that, yes, that is a line of symmetry on that shape.
What about number 2?
So number 2, it looks like they want us to fold it diagonally across. So that would mean that those two opposite corners would have to match up. So if we folded from the bottom to the top like that across the diagonal,
like if we bring this up,
yep, all the way and matched it, I think the part of the rectangle would match, but the problem is we have this whole part of the shape that
it's like jutting out.
Yeah, and that's not going to be the same on top to bottom.
It's like, maybe it would be if there was another one here.
Right, like if, or, yeah, there. Or if they asked us to do a line of symmetry horizontally straight across, like if we had done it that way and folded it from top to bottom, it would be symmetric. But when we fold it on the diagonal, it's not symmetric. So that is not a line of symmetry.
Let's look at number 3, these
So,
two triangles.
yeah, because a line of symmetry can go up, down, side to side, or on angle, like on a diagonal.
Diagonal.
So
So
it looks
what if
like,
we brought this down, like this point of the triangle to this point?
yeah, it looks like both the top and bottoms, bless you, are matching. Like they're both cut, like they're two big, like they're two big triangles that were cut into like smaller half triangles.
Yeah, and it
So
looks like they match.
I'm gonna say yes.
I think so too. Let's look at the next one. So we are being asked here to tell how many lines of symmetry each of the following figures has.
Okay, so like let's not forget a figure is line symmetric if it can be folded on a line to form two matching parts that fit exactly on top of each other.
And remember, we have these 4 ways that we could fold.
Yep.
Up and down, left to right, or on either diagonal.
Diagonal, yeah. So let's try up and down first. And let's try with the letter E. So if we were to fold this, like say side to side, from the left side to the right side, it would not match because we could already see that the left side is very different than the right side of the shape.
Let's try horizontally. Do the top and the bottom of the shape look the same?
Yeah, they do. It looks like it literally was just like cut in half and it's like matching. So the top would match the bottom. So it definitely has a line of symmetry going across.
Let's check the diagonal. I'm trying to put the line into the middle of the shape. That way we can see. Just gonna make it a little bigger here. But I don't think.
No, because if you were to take that bottom right corner of the E and pull it up to the top, it's not going to, you know, if you were to take that bottom left corner of the E and fold it to the top right corner, it's going to be not the same. So it's definitely not diagonal.
So let's try the other diagonal. I think it's the same thing here.
Yep.
Not
Yeah, because both, and again, I feel like because both sides are different on the angles, it's not going to be symmetric. So E does have a line of symmetry, but it only has one line of symmetry. Maybe we can just recopy that and leave it there. Right?
Yeah. But I'm gonna move it on for number 2. Let's look at this shape. Does it work this way?
I think it, actually, at first glance, I thought it did, but now that I'm looking closely, it looks like the top, like, short part and the bottom long part might not match up. Actually, can they? Oh, maybe they do. Can we draw a line from the top corner to the bottom? Yeah.
I think that it would fold over.
Oh, it does. Okay. I was looking like it seems shorter on the bottom, but you're right. Both of those points match up, and the top and the right side of it is the same. So it's great. It was like confusing because it does look. So it has definitely one line of symmetry going horizontally. Let's try it vertically. So if we were to fold it along the line there and fold the left side over the right side, it doesn't look like it's going to match up because I can see the left side is already has different shaped sides than the right. So it definitely is not going to be symmetric that way.
What if we try a diagonal? Let me just move this diagonal a little bit because I think I'm seeing something. What do you think there?
Yeah, so I think that if we were to fold it from the right point across to the left point, yes, from there, and fold it along that line to there, it would match up. Those points would match up. And like, you have to kind of look at it on an angle, but both sides are the same.
It kind of looks like almost like a diamondish shape, like
Yep.
not a diamond, but like how we draw a picture of like a diamond ring, and
Yep.
it like a ring pop actually.
Yes, actually,
And then
that's
we just
exactly what
fold
it makes me
in
think
half.
of. It makes me think of a ring pop, and you folded it in half. Yep. So let's try the other
Diagonal.
diagonal.
I'm just gonna adjust it a little bit because I
Mhm.
think the same thing might be true here. What do you think, Miss Schultz?
Yeah, and again, with those 2 points on either side, if we were to fold it along the line and match up that point to the point on the other side, it would match up perfectly. So I would say that this shape has 3 lines of symmetry.
So let's look at this oval, number 3. I'm gonna start here. What do you think?
So I definitely think if you took the top and folded it over that line to match the bottom, it would match up perfectly. It's like the perfect egg shape.
Yeah, what if we did the same thing and then looked at the 2 sides, left and right?
Yeah, I think if you were to pull the left side over the line to match the right side, it would match perfectly. So I would say that this oval has definitely 2 lines. Should we check to see if it has any diagonals?
We can check the diagonal, but I'm already thinking that it might not be the same shape.
Yeah, because if you were to fold, so yep, if you were to take that bottom side to move it and to fold along the line across, it would be different. They
It's
won't
kind of like
match up.
lopsided.
Yeah, and if it's that way, if that's it for that side, then it can't be diagonal on the other side either.
So what I think I noticed is that if it's diagonal, it must be both diagonals.
I was going to say that. That's something that I was noticing too, especially on the previous one. If it's diagonal one way, then it's definitely going to have another line of symmetry diagonal the opposite way.
Cool. Why don't we take a look at the shamrock?
Yes.
Let me get rid of this diagonal. I'm just going to copy from the E.
Yeah, I'm looking, I can already tell that the top of the shape is different than the bottom. So if we were to fold over that line, it would not match up perfectly. What about diagonal? Let's try that.
Ooh.
Or, okay, vertical.
Oh, sorry. I'm sorry.
So it looks like that is going to be a line of symmetry. Because if I were to fold the left side over the right side, it would match up.
Cool. Let's try diagonal now.
Yeah, no, because if we were to fold along that line, the one side of the clover would not match up to the other. So if it's not diagonal that way, then it's definitely not diagonal the other way. So
what I'm noticing about the diagonal too, it was kind of like a little bit of the left and a little bit of the right were the same. So
yeah.
It had to be a line of symmetry vertically and horizontally in order to be diagonally as well.
True. That's an interesting statement that you noticed.
Because like when we looked at this, I realized that there's no hearts or leaves on the bottom. That was the problem.
So this has 1 line of symmetry.
And this one will pull this one up. Great job.
So now you know how you can recognize and draw lines of symmetry in different shapes.
See you next time.
See you next time.